A wormhole the size of a proton could exist right now, folding space so tightly that a trip of 1 billion light years becomes a single step. But what's even crazier is that the math allowing this was written down over a century ago, and physicists still cannot agree on whether nature ever builds one. Somewhere between fantasy and formula, there could be dozens of different kinds of wormholes, each stranger than the last, and by the end of this list, the very idea of distance will stop making sense. The first kind is the Schwarzschild wormhole. This is the original version, discovered inside the same equations that describe a basic, non-spinning black hole. It connects two separate regions of spacetime through a throat of curved geometry, like a bridge tucked inside the fabric of the universe itself. But here is the unsettling part. This bridge collapses faster than light could ever cross it, snapping shut before anything gets through. No stability, no shortcut, just a mathematical ghost. But the next one on this list actually tries to fix that problem. That fix is called a traversable wormhole, and it requires something physics has never confirmed exists in the right form. To hold the throat open, you need negative energy density, a kind of exotic material that pushes rather than pulls. Take normal matter, invert its gravitational behavior, and you get a wormhole that could theoretically stay open long enough for a spacecraft to pass through. We have never detected this exotic matter directly, but the equations demand it if a stable tunnel is going to work. And this is where things become strange, because some versions of quantum theory hint that tiny amounts of this negative energy might already exist, just not nearly enough. So what happens if you take that tiny sliver of exotic energy and multiply it across an entire structure? That question leads to the Morris-Thorne wormhole, one of the most famous traversable models ever proposed. It describes a symmetric tunnel with two mouths, no event horizon, and no crushing tidal forces at the entrance. Unlike a black hole, you would not be torn apart just from getting close. If you've made it this far into the architecture of space-time, drop a like, because the next entry on this list turns one of these tunnels into a literal time machine. That entry is the Wormhole time machine, a theoretical setup where one mouth is accelerated near the speed of light while the other stays still. Time moves differently for each mouth once relative motion enters the picture, according to relativity's basic rules about moving clocks running slower. Move one end for years, then bring the two mouths back together, and stepping through could mean stepping into your own past. Physicists call this a serious problem, not a convenience. No clean loophole, no free pass around causality, just an open question. But the next kind of wormhole does not just bend time, it questions what a black hole even is on the inside. That is the Einstein-Rosen bridge, named for the two physicists, who first derived it directly from general relativity in 1935. It describes a black hole and a white hole connected at their throats, one side pulling everything in, the other side, theoretically, pushing everything out. But nobody has ever observed a white hole, and many physicists suspect the geometry might not survive contact with real collapsing matter. Still, this bridge is the mathematical seed every modern wormhole theory grows from, a hidden thread running underneath 100 years of physics. And that leaves us with a version that doesn't just connect two points, it might connect two entirely different universes. This is the interuniversal wormhole, a proposed tunnel that does not link two locations in our universe, but two separate universes entirely. In this model, the throat never opens into anywhere reachable, because the other end sits outside our own observable reality altogether. No return trip, no message home, just a one-way handshake between separate realms of existence. If such a structure exists, it would mean our universe is not sealed. It is simply one room in a house with doors we cannot see, But the next wormhole variant turns that unreachable connection into something even harder to imagine, a tunnel with no ends at all. That is, the wormhole without event horizons, sometimes modeled using a hypothetical particle called a ghost field. Unlike a black hole's version, this tunnel would have no boundary of no return, meaning light and information could move freely in both directions. Take away the one-way barrier, and suddenly the tunnel behaves less like a trap and more like a corridor. Physicists studying this version in the 2010s used it to explore whether information could survive a trip through curved spacetime without being destroyed. But the next type on this list does not just preserve information, it multiplies the paths that information can take. That leads to the concept of a wormhole network, sometimes discussed in relation to the ER equals EPR conjecture proposed in 2013. This idea suggests that quantum entanglement itself, the strange link between particles that share a fate no matter the distance, might be mathematically identical to a microscopic wormhole. Take two entangled particles anywhere in the universe, and according to this conjecture, a tiny bridge connects them instantly. Wormholes would not be rare exceptions. They could be woven invisibly through every particle interaction happening right now. But the next entry asks, what happens when this same bridge grows to a size we could actually detect? That question defines the astrophysical wormhole, a theoretical candidate that some scientists have proposed might explain unusual gravitational lensing patterns spotted near certain galactic centers. If light bends in a pattern that does not match a standard black hole model, one explanation on the table is a wormhole throat instead of a singularity. Nobody has confirmed this for any real observation, and most unusual lensing cases still get explained by ordinary massive objects. But the search itself matters, because it means astronomers are no longer treating wormholes as pure fiction. They are treating them as a testable hypothesis. And that testable hypothesis becomes far stranger once you consider what could be living at the far end of one. This next kind is the rotating wormhole, modeled after the way spinning black holes drag the space around them, in a process called frame dragging. Give a wormhole throat angular momentum, and the geometry stops being simple and symmetric, twisting instead like a whirlpool carved into space-time itself. A rotating tunnel could theoretically be held open with less exotic matter than a static one. According to several theoretical papers published in the 2010s, spin changes everything, even in a structure built from pure geometry. But the calmest sounding version on this list might actually be the most unsettling of all. That is the thin shell wormhole, a model where the exotic material needed to keep the tunnel open is concentrated into an impossibly narrow boundary layer rather than spread through the whole structure. Picture a soap film stretched across a tunnel mouth, except this film is made of negative energy density, holding two universes apart. Physicists use this model because it simplifies the math, isolating the strange physics into one thin, calculable seam. Shrink the exotic material down to almost nothing, and the wormhole still theoretically holds. But even a wormhole this efficient is still bound by one final unresolved problem that towers over every version on this list. That problem defines the final entry, the quantum wormhole, sometimes called a Planck scale wormhole. At the smallest conceivable scale of reality, roughly 10 to the negative 35 meters, some physicists suspect space-time itself is not smooth, but foamy, riddled with microscopic tunnels flickering in and out of existence faster than they can be measured. If this is true, wormholes would not be rare cosmic anomalies at all, a constant, invisible hum underneath the ground beneath your feet, underneath your own body, underneath every second that passes. No confirmation exists yet, and it is possible none ever will, because the scale involved may sit forever beyond what any instrument could detect. If you made it through every fold in this list, you have just walked through the strangest bridges physics has ever written down, and every single one of them is still waiting to be proven. Subscribe before space finds a shortcut around you, and if you are not ready to leave this bent, tangled version of reality behind, there is a full playlist waiting, exploring exactly how far these tunnels might go.